Okay, I'm going to go over the quiz and then do somewhat of a review, give you a study guide for the test next time. Okay, so find a component form of a vector if you know the initial point and the terminal point, right? What's the math? Terminal minus initial. And remember, it is important that when you're making a vector, if you're going to show it in component form, you need the angle brackets. If you use parentheses, it's not altogether right, because that's how we say a point. And so make sure you use the right kind of things. This one would have been negative 3 minus negative 2, which is negative 1. 6 minus negative 3, which is 9. Done. Right? Just subtract. Terminal minus initial. Right? Find the magnitude and the direction angle. I would say 80% did not even try to find the direction angle. I guess you probably didn't even, you just kind of glossed over it when you read the question and don't even realize it's asking you for something. You got to read the whole thing. I mean, the magnitude of this vector, right? The magnitude of V is the square root of 5 squared plus 4 squared, which is the square root of 41. Most got that, but then again, didn't do the direction angle. How do you find the direction? What is the direction angle? I mean, what does it mean, the direction angle? If my vector is here, then where on there would I find the direction angle? Okay? It's from the positive x-axis in a positive angle direction, right, counterclockwise. So it's the positive angle that goes from the positive x-axis. That's theta. Okay. So how do you find it? Tan inverse. Okay, what goes inside the tan inverse? 4 over 5, right? It's because again, if you're dealing with triangles like that, you know, the tangent is the y divided by the x, right? So it has to be 4 divided by 5. And that was 38.7. Could I ask the same kind of question of a vector in space? One angle would not be sufficient to identify the location of this vector. I mean, it's still got a magnitude, which is, we know how to find the magnitude of a vector in space. But there's not just one angle that would tell you where to go. You would have to use 2 angles, right? If you know the distance, you have to go, let's say, from the positive x-axis, and then let's say you could say from the positive y-axis. And then with those 2 angles and the length, you would know where you're at. But we don't do it that way. So you could only get asked that question, direction angle, if it's in 2 dimensions. Okay. Right. Given 2 vectors, find 2u minus 3v. Okay, so 2 times 5 negative 1 minus 3 times 2, 7. All right, what do you call that operation right there? Scalar multiplication. And how do you do it? Yeah, it's like distributing, right? So you say 2 times 5 is 10. 2 times negative 1 is negative 2. 3 times 2 is 6. 3 times 7 is 21. And how do I do that? That's a scalar, or sorry, that's a vector subtraction. How do I do that? Just subtract, right? 10 minus 6, 3. Oh, sorry, 4. I was thinking something different. 4. Negative 2 minus 21, negative 23. think there was maybe somebody that then found the magnitude or something like that. Made a unit vector, didn't ask for it. This one, there was a mistake in the problem. Did you see the mistake? Yeah, I should have made it a bold V, and it's not a bold V, but that's an essay. Good one. Okay. Find a unit vector in the direction of V. Again, we just did that, right? How do you find a unit vector in the same direction as that vector? You take the magnitude, divide by magnitude, right? So what is the magnitude of this vector? The square root of negative 4 squared plus 7 squared, which is 49 plus 16, 65. Right, so the V divided by the magnitude of V, I mean, in the book, they usually write it like this: 1 over the square root of 65 times negative 4, 7, to show it as a scalar multiplication. And you could even rationalize this root 65 over 65. Or you could write it like negative 4 over the square root of 65, comma, 7 over the square root of 65. Right? Or you could write it negative 4 square root of 65 over 65, and 7 square root of 65 over 65. Okay. So a unit vector in the same direction, find the magnitude, divide by that. It is a scalar multiplication. We know scalar multiplications don't change the direction. That's why we are going to get a vector that's still going in exactly the same direction. And then find the angle between two vectors. What's the formula to find the angle between two vectors? U dotted with V well, that's half of an equation equals what? Cosine, right? The cosine of the angle in between is the dot product divided by the magnitude of one and times the magnitude of the other. So that's the three things we got to fill in right over there. So what is the dot product? Negative 1 times 6 plus 0 times 2. Right? The dot product is a scalar. It's negative 6. Right? The magnitude of U equals, what's the magnitude? 1. Right? What's the length of a vector that goes from 0, 0 to 0, negative 1, or negative 1, 0? And what's the magnitude of V? The square root of 6 squared plus 2 squared, which is the square root of 40. So plug all that in, right? Cosine of theta equals negative 6 divided by the square root of 40, which is negative 0.9487. So what kind of angle are we going to get when we do the cosine inverse? Because that's negative, the angle will be obtuse, right? Because you know that the cosine, right? The cosine is positive in the first quadrant and it's negative in the second quadrant. So if the cosine equals a negative number, you're going to get an angle which is somewhere over there, obtuse. Okay, now do the cosine inverse and you get 161.6. Any questions on any of that? Okay, so here's a review, preview, study guide kind of thing. at the end, I'll give you some problems that you can use as the study guide. Right. Find vectors given initial and terminal points. Okay, like the first quiz question. Right. Now, on the quiz, it was in the plane. But you could do the same thing in space. So you could do it if you had three components or three x, y, and z coordinates to the points. You could do the same thing, right? So it really doesn't change it much to have it done. Find the magnitude of vectors, right? We did that on the quiz too, right? It's not much different if it was 2 dimensions to 3 dimensions. It's still a square root of the sum of the components squared, right? Find a unit vector in the same direction. How do you do that? There's also on the quiz. Divide by the magnitude, right? You already know how to do the magnitudes. Divide by the magnitude. That's it. And it wouldn't work much different in 3 dimensions as it does in 2 dimensions. So not really, shouldn't be much tricky with that. Okay, find the direction angle of a vector in the plane, right? You could only do that if you have a 2-component vector, right? It wouldn't make any sense in 3 dimensions. If you remember, the one question where we had to do something like that, which I know is one of the highlights of the last 2 weeks for you, was when we did that, the weight was suspended in space, and we had to find the balance of forces between. It ended up using a system of equations, 3x3 matrices to solve all that. Because we didn't have direction angles to deal with, we had to come up with, for the direction, we had to use a unit vector in the same direction as we were pulling. Okay. Now, find a vector given a magnitude and a direction. And this is one that, when we did this, I want to go to the book. And let me go to, see if I got that. 6-3. 6-4. And then go backwards. I don't recall that people asked many questions about this, so I can tell you that we didn't do very well with it at all. But when it says find the vector, if you know the magnitude of the vector and the direction that it's going in, right? These ones said find the vector v with a given magnitude and in the same direction as u. Okay, so let's say the number 49. The magnitude of the vector is going to be 10, and it has to be in the same direction as -3, 4. So let me do that. Magnitude of v is 10, and u is -3, 4. I mean, ultimately, we're going to plug this into this formula. The vector v equals its magnitude times the cosine of the direction angle, the sine of the direction angle. Right? And they've given you this. I mean, that part is done. You just have to come up with the right direction angle with that. How do you find a direction angle? We just did this, right? Tan inverse of 4 over -3. So you would take a step, theta equals tan inverse of 4 over -3. And then you would take that theta and put it here and here. And then you already know that. So again, that was a homework problem. We did a 49 and 51, I think. And even if you didn't ask questions, I know there was a lot of people were stumped on that first one. Oh, we're still on that page. So find a vector given a magnitude and direction. Okay, basic vector operations. The basic vector operations means scalar multiplication, add, subtract, that kind of thing. Kind of like the quiz question. You know, here's some vectors. You know, find 2u plus 3v kind of thing. So I don't think that's probably too complicated. Could be done in 2 dimensions or 3 dimensions. Again, this thing here, right? could not really be done in 3 dimensions, not the same way, because you don't have a direction angle. I mean, you could find if this was in 3 dimensions, let's say U was in 3 dimensions, 1, 2, 3, right? I could find the unit vector in that direction and then multiply by the magnitude, and that would be it. But I couldn't come up with a direction angle to plug into something like that. Okay, so, you know, I put on the add vectors, even though we just said you have to do basic operations, just to understand, you know, maybe in the context of a word problem or something like that, you know, if you have to add the vectors, what is the process to add vectors? What are you adding up specifically? You add up the components, right? So if it's not in components, like a lot of those weren't, you know, it would tell you the plane is flying in this direction and at this angle, and the wind is at this direction and at this wind speed and this angle. You know, you had to turn those into components. You can add the components. So remember that you got to have components to add the vectors. Add components. Okay, do we know how to do dot products? Right, you need to know this, right? How to do a dot product, 2 dimensions, 3 dimensions, works the same. Find the angle between 2 vectors. Got to know the formula. It's not being given, right? Know the cosine theta equals dot product divided by. Actually, right, this is the formula. Cosine of theta equals U dotted with V divided by the magnitude of U times the magnitude of V. Missing a line there. But we actually came up with another formula later. Do you remember that? When we got to cross products, it turned out that the sine of theta equals the magnitude of the cross product divided by the magnitude of U, magnitude of V. Now, given the choice, you probably want to use that one before you'd want to use that one. And remember, if you're given 2 dimensions, you could only use that one because you don't have a cross product in 3 dimensions. It only works in 2. So find the angle between 2 vectors. Okay, check for orthogonal and parallel vectors. How do you know if 2 vectors are orthogonal? They equal 0. They're both 0 vectors. The dot product equals 0, right? Orthogonal is dot product equals 0. Product. Okay. How do you know if 2 vectors are parallel? They're scalar multiples of each other, which means, yes, you can divide their respective components. You should get the same constant every time, right? Parallel vectors, scalar multiples. Just related question. How do you find a vector which is going in the opposite direction? You just make them all negative, right? The opposite of what the component, make all the components opposite of what they were. Okay, remember the only thing we did out of 11.1 was understanding space. Remember with that great PowerPoint? Man. If I would have shown that before, I could have got Teacher of the Year, but I waited too long. So remember, how do we know it's positive X is coming out of the board here. Positive Y is in that direction. Positive Z is up. Negative Z is down. How do we identify the octants that make up space? Where's 1? It's where they're all positive, right? This piece right here where X is positive, Y is positive, Z is positive, that's 1. Right? How do I find 2, 3, and 4? You go around the Z-axis counterclockwise, right? 1, 2, 3, 4. Okay, then where do I start with 5? Right below 1 is 5. 5, 6, 7, 8. So 1, 2, 3, 4, 5, 6, 7, 8. We did those problems which were 21 to 26, you know, and some of them they gave you more information than others. Sometimes it said like which octants is x times y greater than 0, right? You should be able to figure out what that is. So name the octants. Okay, be able to do a cross product and understand what it represents. I mean, what does the cross product of two vectors produce? Another vector which is orthogonal to the two vectors that you started with. That's the whole point. And you're likely to get a question that says, find a vector which is orthogonal to. It won't say find the cross product. You have to know that part. If you don't know it, then you won't know where to start. So you got to know the cross product. You got to know what it means and what it's used for. How do you find the area of a parallelogram, or for that matter, a triangle? The magnitude of the cross product, right? If it's the parallelogram, it's that, you know. If it's the triangle, divided by 2, because the triangle is half of the rectangle. And, you know, you're going to get some which are going to be the component form. There's going to be some linear combination of the standard unit vectors I, J, and K, right? So you need to be able to work with both. And you need to know there's not that many formulas, but, you know, if we're going to say formulas, even finding the component form of a vector, if you know the initial and the terminal point, terminal minus initial. Find a magnitude, right? Square root of the sum of the squares of the components. How do you find the direction angle in 2 dimensions? Tan inverse of the V2 divided by the V1, the y component, let's say, divided by the x component. How do you find a unit vector in the same direction? The vector divided by its own magnitude. How do you find the angle between 2 vectors? The cosine theta, right? Cosine theta equals dot product divided by the magnitude of one times the magnitude of the other. Did we add anything? Then we went to the next, we went into 3D. Everything was the same until we got to the cross product, and then you need to know how to do a cross product. Any questions about that? So these really are just pointing you at problems where you do all that stuff, right? You could tell that from these two are in the plane, right? These 3 are in space. And there will be an extra credit problem that is more like, it'll come from the plane. There'll be some kind of balance of forces or something like that. It might involve systems. I haven't wrote the test yet, so it'll be something like that. So if you go to the page 428, these are all the word problems in the end. Similar to that, but that will be the extra credit problem. Okay. Questions? No?